Welcome. This is Mrs. Rutchling, Chapter 10, Double and Triple Covalent Bonds. Atoms can share 2 or 3 pairs of electrons, they will. So for us, carbon, nitrogen, oxygen, phosphorus, and sulfur are atoms that can form multiple bonds. A double covalent bond, as we see here in oxygen, 2 pairs of electrons. We can also represent those 2 pairs by the 2 lines here. Nitrogen can share 3 pairs, and so that is also shown either by the 6 electrons or the 3 dashes. Let's try to draw a Lewis structure with double bonds. We have carbon, hydrogen, and oxygen. This is a carbohydrate, carbon and water. Carbon is often the central atom. If we look at valence electrons, carbon has 4, each hydrogen has 2, and oxygen has 6. Looking at octet electrons, we have carbon and oxygen that require 8, so that's 8 multiplied by 2, and then hydrogen would form a duet, so that's 2 multiplied by 2, add them together, we get 20. If we find the difference for our bonding electrons, we have 8 bonding electrons, then we have 4 bonds, since each bond has 2 electrons. Lastly, we calculate the number of extra electrons by finding the difference between the valence electrons and the bonding electrons. That gives us 4, so 2 pairs. If we draw carbon in the center to the elements that are there, now I have 3 bonds, but it says that there are 4 bonds. This is your clue that there is going to be a double bond somewhere. Well, the only atoms in this molecule that can form double bonds are carbon and oxygen. So I can add another bond. Now carbon has a full octet. Hydrogen has a full duet. Hydrogen has a full duet. Oxygen, however, only has 4 electrons, so it's going to need 4 more, or 4 extra, to fill the octet.